Welcome, ladies and gentlemen, to this video lecture. So in our previous lecture we determined an approximation for the sine of 1 by evaluating p5 at 1, and now we want to show how accurate our approximation is. How close is our approximation to the actual value of sine? And what we will do is we will apply this theorem. So we have already determined the fifth Taylor polynomial about 0. So, and now we want to show that our error is less than 1 over 720, and we will use this theorem. And all that we need is a bound for the sixth derivative for all numbers between a and 1. Okay, but we have already determined up to the fifth derivative, so let's determine the sixth derivative for good measure. That is minus sine x. And so with that we know, well, what does the sign look like? Sine looks like that, but we're working with a minus sign. Point is, everywhere for all x, the value of sine is between 1 and minus 1. So the absolute value of minus sine is always less than 1. So for all t, oops, not natural numbers, it holds for natural numbers, but for all real numbers, the sixth derivative of f of t is less than or equal to 1. So let's add here for good measure, specifically specifically with an F, specifically also for all t. What are we interested in? We are interested in the values of the derivative between 0 and 1. Why 0 and 1? Because we have our Taylor polynomials computed about 0, and we are interested in the value of our function at 1. So this bound only needs to hold between all numbers between the a about which you are expanding your Taylor polynomial and x, the value in which you want to determine the error at. So specifically for these values, we also have that the sixth derivative of f of t is less than or equal to 1. Okay, therefore the difference between the actual value of sine of 1 and our approximation, this is exactly the error, how the error of the fifth Taylor polynomial at 1 is defined. And by theorem 4.8.8 we have that, actually let's put it up here. So by theorem 4.4.8, e5 of 1 is less than or equal to 1 over 6 factorial 1 minus 0 to the power 6. Just plugging in everything here. And now working out what is this 1 over 6 factorial 1 to the power 6, which is 1 over 720. Okay, so we know that our approximation is at least within a 1 over or a 720th. So we know, let me write it this way, p5 of 1 is in somewhere in the interval sine of 1 minus 107.20, comma, sine of 1 plus 1 over 107.20. So it is somewhere in this interval. Okay, and that is it for this example. I will see you in the next one.